Okay, so now that we have a general feel of how this is going to work, this video should be much shorter. Getting right into it, you guys, if you want to copy down some definitions here, we have a power, a base, and an exponent definitions here. Again, what I would really copy down is this right here. We have the power 3 to the 4th, we have our base is 3, we have our exponent is 4, and then it's written out as repeated multiplication. And you'll see some of this in your homework. It'll tell you to write out the power as repeated multiplication, or it will tell you to take a repeated multiplication problem and write it as a power. But a lot of us have seen this before. 3 to the 4th power means we take 3 times itself 4 times. We have some shortened terms here, 3 to the 2nd power, or we can say 3 squared, 3 to the 3rd power, or we can say 3 cubed, and then we have 3 to the 4th, and so on. Writing the product as a power, again, product means to multiply, so you'll see that we have some problems here that are all hooked by multiplication. So we have 4 times 4 times 4 times 4 times 4. If we just count those up, I have 1, 2, 3, 4, 5 bases that are the same. My base always stays the same, and then I change my exponent to a 5 because I had 5 times that I had written that for. Same thing with 12 times 12 times 12. I count them up, 1, 2, 3. My base stays the same. I write 12 to the 3rd power. Those are pretty straightforward. So what I want you to do is pause real quick. Go ahead and try 1 and 2. Now that you've had a second, you should have the base of 6. And if we count 1, 2, 3, 4, 5, 6, we have to the 6th power. So my base and my exponent are both 6. The next one, we have 15 as a base, and we have 15 to the 4th power. This next part is also pretty simple, you guys. What we want to do when we want to evaluate a power is we write it out. So up here we have 7 to the 2nd power, or 7 squared. So what the book does is say, okay, we're going to write out our bases however many times, and then we're just going to solve. 7 times 7 is 49. Same thing for 5 to the 3rd. So right here they wrote it out, 5 times 5 times 5 times 5. Once we write it all out, you guys can multiply this. 5 times 5 is 25, times another 5 will give us 125. Example 3 is one that should be pretty simple in here, especially if you take advantage of those multiplication tables that we have. Most times when we talk about perfect squares, we won't go past 400 for perfect squares, so we'll get up to 20 times 20, but past that we won't really go very far. So the square of a whole number is a perfect square, which means if I take any whole number such as 3 and I square it, well, the square of a whole number 3 is 9, so 9 is a perfect square. Example 3a asks if 64 is a perfect square. Well, if I want to figure that out, I can say I'm not really quite sure, so I can just start taking numbers times themselves and get to the point where I get to 64. So let's say I start at 5. Well, 5 times 5 is 25, that's not big enough. 6 times 6 is 36, not big enough. 7 times 7, 49. 8 times 8, 64. We can see that that's a perfect square, so we can just write yes, it's a perfect square. For example B, 20, if you start at 4, you have 4 times 4 is 16, and 5 times 5 is 25. So obviously 20 is not a perfect square. So what I'd like you to do now, again, is go ahead and pause. Try these examples at the bottom of the page. Go ahead and write them all out. On 3 through 6, you're supposed to solve like we did in example 2, and then in 7 through 10, you're supposed to tell whether it's a perfect square or not, like we just did in example 3. This is also in your textbook, you guys. This is just an illustration showing you how perfect squares work with shapes. It says the area of a figure is the amount of surface that it covers, and the area is measured in square units. So if I talk about a square that has a side length of 3, well, we know that squares have the same sides, all 4 sides. So we can count 3 units here and 3 units along this side, and then we can see all 9 squares on the inside. So if it's a 3 by 3 square, we would take 3 times 3 and get 9. Okay, right before we finish up here, we have a couple real-life application problems. Again, I'm just going to leave the work in there. It asks for the area of a Monopoly game board. It's a square, obviously you can see from the picture. The side length of it is 20 inches, so to find the area we're going to take 20 and we're going to square it. 20 times 20 gives us 400, so when we go to put our unit of measurement, we're going to put 400 square inches. Go ahead and take a look at this stop sign, pause for just a second, and see if you can't find the area of the stop ahead sign for the schools. Okay, now that you've had a second, hopefully you've multiplied 24 and written it like this, 24 squared, and then when we do that, we multiplied out 24 times 24, and we should get 576 inches squared. So here's our assignment again. To find the book material, it's in the eBackpack Chapter 1 folder under book material, and you're just going to scroll until you hit page 14 or until you see the section 1.2 pop up, and then go ahead and do these problems 2 through 32 even, and then 40 through 44 all.